This is Mr. V. Welcome to this video series on linear programming. This video is going to be about variables and parameters when we have three variables to work with. So, as a reminder, variables are the quantities that we are able to change in the question, while the parameters are the quantities that do not change. So here we've got our problem. We've got a cinema which sells tickets for $12 to adults and $8 for concession. Now we're going to have to use that information to try and figure out our equation. And then we're going to use the value for one session to try and be able to draw a graph. So we've got multiple steps going on here, and we've got to be careful that we don't stuff that one up. So we'll start with our variables and parameters. So I'm going to list my variables, and I'm going to list my parameters. And I'll start with my variables. So looking at this question, we've got money, money, money. They're all some sort of money value. So one of my variables obviously is going to be a money. And we're talking about the cinema earning money. So this will be the earnings of the cinema. Should be one of our variables. Now one of our other variables is the number of adult tickets that we sell. So we're going to have adult tickets as one of our variables. And we've got these concession tickets. So we have three variables in this problem. And somehow we're going to have to deal with that. I might call this E for earnings, A for adult tickets, and C for concession tickets. Okay, now let's look at these parameters. We've got $12 per adult. So that's a parameter that's linked to the adult tickets. We can't figure out how much you earn unless we also know the number of adult tickets. So $12 is my parameter here, $12 per ticket. And it's going to cost $8 per concession ticket. So this parameter is down here. We also know that the amount taken for one session is 2,400, which means at some time our earnings is equal to $2,400. Now note that we don't need to know this value to be able to calculate our earnings. This is actually a value that we've got. So it's separate from a parameter linked to variables. It's an actual value that we know. Now we want to figure out the equation for total takings, or earnings is what we wrote down. So we want E equals something. Now in our case, to figure out our earnings, we need to know the number of adult tickets and multiply that by $12 per ticket. And we're going to add all of the money made from the concession tickets, which is $8 times the number of concession tickets. So my equation is going to be E equals 12A plus 8C. Now my last step is to get this equation into a form that we can graph. We can't graph something that has three unknowns because we only have two axes, so we need two unknowns. And that's where we're going to use this E equals 2,400 value. So we know that one particular day, that's what the earnings was. So starting with my equation, I'm going to substitute this value in. So substituting that in, we're going to have 2,400 equals 12A plus 8C. Now we want to make one of these two variables the subject of the equation. I'm just going to pick one. I'm going to pick C. So I want to rearrange this form so that at the end I've got C equals something. Let's work through that, shall we? So subtraction or addition terms go first. We have this plus 12a. So to get rid of that, we're going to take 12a from both sides. I'm going to have 2,400 minus 12a equals 8c. Now I'm going to look at my multiplication or division terms, and I can see that I've got this 8 times c term. So the opposite of times 8 is divide. So I'm going to divide both sides by 8. Oh, sorry, no 8 there anymore. So we're dividing this side by 8. Now let's simplify that. 2,400 divided by 8 is 300, minus 12 divided by 8 is 1.5, times A equals C. Now lastly, I want this to look like the form y equals mx plus c. So I'm just going to rewrite this to make it look nicer. I'm going to have c equals minus 1.5a plus 300. And now I can move on to graph this equation using either the intercept method, gradient method, or table method.